This is section 4.2, combining and composite functions. And this is probably going to be the hardest section that we have, especially when it comes to the composite functions. All right, so let's look at this. F of x is 5x squared, and g of x is x plus 2. And we need to find all four of these, and we need to find the domain of f of g of x. All right, so f plus g of x is another way of saying f of x plus g of x. So here's f of x, and then here's g of x. F of x is 5x squared, and g of x is x plus 2. Now, at this point, you would simplify or reduce things, but we can't do anything here, so that one is done. This one is f of x minus g of x. F of x is 5x squared. When you subtract g of x, you need to put it in parentheses. All right, so from there, we need to get rid of parentheses by multiplying through by that -1. So it's 5x squared minus x minus 2. And all we did was change the signs inside the parentheses. Sorry about that. And we can't simplify anything, so we're done with that one as well. All right, this is f of x times g of x. So f of x is 5x squared. G of x is x plus 2. And once we get that, we're going to distribute. We're going to take 5x squared and multiply it by everything inside that second set of parentheses. 5x squared times x gives me 5x to the third power because I have 3 x's. Then 5x squared times 2. 5 times 2 is 10, and I have 2 x's. So it's 10x squared. D is f of x over g of x. F of x is 5x squared. G of x is x plus 2. And there's nothing else you can do with that. Now, there's going to be a part E where they want you to find the domain of the one that we just did. So you're going to take the bottom. We're not worried about the top, and set it equal to 0. And then we need to solve for x. So we're going to subtract that 2 from both sides. So x is equal to -2. That means x can be anything but -2, because if I plug a -2 in here, the bottom goes to 0, and we can't have the 0 on the bottom of a fraction. They do want the answer in interval notation, so I'm going to show you how to do this. Where you start with a parenthesis, and we're going from -infinity to -2, which has a parenthesis. And then you have this symbol, it looks like an uppercase U, and I'll show you how to find it. Open a parenthesis, -2 to positive infinity. This means it's every number except for -2. So in my math lab, when you click in the box to put your answer, that little box pops up at the bottom. That where your infinity is, they will also have that union symbol. Don't use a capital U, use the union symbol at the bottom of the page. Right, we have f of x and g of x. So we're going to add those two together. And then from there, we're going to combine like terms. So 3x and x are the same. They both have single x's on them. 3x plus 1x gives me 4x. Then 6 and negative 9 are the same because they're just numbers. So 6 minus 9 gives me a negative or minus 3. The first problem we did, we didn't have to simplify anything. This one we do. So the problems are going to vary as to whether or not you need to simplify your answer. Again, we have f of x minus g of x. Write down f of x. And when I subtract g of x, make sure all of it is in parentheses. I need to distribute the negative to what's inside the parentheses, and that just changes signs of everything that's inside the parentheses. So that becomes minus x plus 9. So we have a 3x and a minus x. So 3x minus 1x gives me 2x. And then 6 plus 9 gives me 15. The next one is f of x times g of x. Right, so 3x plus 6 times x minus 9. We are going to have to multiply this out. So 3x times x is 3x squared. 3x times negative 9 is negative or minus 27x. Then we do the same thing with the 6. 6 times x is 6x. And then 6 times negative 9 is going to be negative or minus 54. With this one, our two middle terms are the same. They both have single x's on them. The other terms have nothing in common, so we're just going to bring those down. Negative 27x plus 6x. So negative 27 plus 6 is negative 21x, and then bring down the minus 54. All right, d is f of x over g of x. And then part E, the domain, you're going to take the bottom of that fraction and set it equal to 0. At this point, we solve for x by adding 9 to both sides. And we get x is equal to 9. So what happens is if we plug 9 into the bottom of this fraction, we get 0. So x can be everything but 9. They want the answer in interval notation, so we're going to go from negative infinity to 9, union 9 to infinity. And that's how we write the answer. All right, so this one has numbers plugged in. My math lab shows you a different way to do it than I'm going to do it. You can do it either way. Both methods are correct. I feel like this one's a little bit easier, but you're free to do it how they do it. So this is the same as f of 2 plus g of 2. To find f of 2, you're going to plug 2 into f. Right? That's going to be 4 minus 14. Gives me negative 10. And then I also need to find g of 2. And then like this right side here, you can put this part straight in your calculator. That should be a cube, not a square. Okay, so 8 minus 2 cubed, that is going to give me 0. All right, so then I have f of 2, which is 10, plus g of 2, which is 0. So my answer is negative 10. All right, so part B, be careful now because they don't have f minus g, they have g minus f. So that's g of negative 1 minus f of negative 1. So let's find g of negative 1. The negative 1 needs to be in the parentheses. The cube needs to be on the outside. Okay. So that is going to give me plus, that's going to give me 9. That's going to give me 8. So g of 1 is 9. F of negative 1 is 8. 9 minus 8 gives me 1. Now we have f of 1 times g of 1. And again, you can just put the right sides straight in your calculator to evaluate that. Make sure if you do that everything's in the same order, like the exponents are outside the parentheses. If you put it in exactly like this, once you hit enter, it may change it a little bit. But if you put it in exactly like I have it, it'll come out just fine. Okay, so you have 1 minus 7, which is negative 6. 8 minus 1, which is 7. F of 1 is negative 6 times g of 1, which is 7. And it's going to give me a negative 42. So our last one, again, F's not on top on this one, G is. So we have G of 4 over F of 4. That up. So one is negative 56. This one, negative 12. All right, so G of 4, which is negative 56, over F of 4, which is negative 12. Negative 56 over negative 12. So that's going to give me a positive 14 over 3. So you do need to reduce your fractions, and you can just put it in the calculator like I did, and it'll reduce it for you. All right, so this is composite functions. So this is the most difficult one, these types. First time I learned it, it didn't click the first few times, and then once I started doing it and practicing it, it made more sense. So, this is an open dot. So it's f of g of x, not f times g of x. So basically what you're doing is you're taking g of x and you're plugging it into f. Okay. So I'm going to do f of whatever g of x is. It's on the inside. We're going to put that there. So that's 3 minus 4x. For f, wherever there's an x, we're going to plug in that expression instead of like a number. Okay. From this point, you're just going to simplify. So 3 times 3 is 9. 3 times negative 4x is negative or minus 12x. And then bring down the minus 1. We can combine the 9 and the minus 1. So 9 minus 1 is 8 minus 12x. If you put negative 12x plus 8 in, that's the same thing. That's fine. That order's not important. I don't know what this thing is doing. All right. I think when I draw a straight line, it's trying to make it into an image. All right, so this one, it's in the opposite way. It's g of f. So this time f is on the inside, which is 3x minus 1. G is on the outside, so I'm going to write g with a big set of parentheses and plug in f. At this point, we're just simplifying. So negative 4 times 3x is negative or minus 12x. And negative 4 times negative 4 is positive or plus 4. I can combine the 3 and the 4, so that's going to be a 7 minus 12x. We're going to do a few more of these. And the composition of functions only have 2 parts. The other ones have more than 2. All right. So we're going to do f of g of x. G of x is 5 over x. F is on the outside. So I'm going to put a big set of parentheses where there's an x. So think of it as like when we go to plug in a number, how we would set it up and then put the number in. But instead of the number, we're putting in another expression. Now the square, we square the 5, which is 25. And then we also square the x because the square is on the whole fraction, not just the top or just the bottom. So we get x squared. Then I multiply across. 3 times 25 is 75 over x squared. Opposite direction, g of f of x. F of x is 3x squared. Then we write out g with a big set of parentheses where x is. And we plug in the 3x squared. Now this one, there's nothing we can do other than just drop the parentheses. And we're done. All right. So we find f of g of x. G of x is the square root of x plus 3. And I write f with a set of parentheses, just as if I was going to plug in a number. But instead of plugging in a number, I'm going to plug in an expression. All right, so when you simplify the square root, we don't distribute the 3 that's on the outside to stuff that's on the inside. You can only form operations inside the square root or only outside, but not from inside to outside, okay? So we're just going to drop the parentheses. And that's all we can do with that one. And then we're going to find g of 3x plus 2. That's what f of x is. We write g all the way out with a big set of parentheses where the x is. Again, just like we would be plugging in a number. But instead of plugging in a number, we're going to plug in 3x plus 2. Now, since everything is underneath the parenthesis, or underneath the square root, we can simplify from there. Meaning we can add that 2 and that 3 together. And that's all we can do with that one. So we need to find f of g, which is 9x. All right, f with a big set of parentheses, wherever there's an x. But instead of plugging in a number, I'm plugging in an expression. Again, there's nothing else you can do in here besides just drop parentheses. And we are done with that one. All right. Second part, we plug in f of x. So that's going to be the absolute value x minus 7. I write g with the big set of parentheses where the x is. And plug in that expression. So if I drop the parentheses, I can't distribute the 9 inside there. So that's all we can do at this point. At a certain school, the number of tickets sold for a home football game can be modeled by this equation, where P is the winning percent of the home team. The number of tickets sold for this game, the number of non-student tickets sold for this game is given by this equation. So we have student ticket equation and non-student ticket equation. Writing equation TP for the total number of tickets sold for a home football game as a function of the winning percent. So the total number of tickets sold would be the student tickets plus the non-student tickets. So we're just going to add these two together. About that. And then we need to simplify. All right, I have p squared. I only have one term like that. I have two terms with just a single p, so I'm going to add those together. 86p. And then two terms that are straight numbers. I'm going to throw that in a calculator real quick. And that gives me 13,300. So that's the equation for the total number of tickets sold based on the percent of games that the home team wins. What is the domain? Okay, so domain are your X values. And the X values are percents. So the lowest percent of the games that they can win is 0. The highest percent of their games they can win is 100. And that is inclusive. So we have to have brackets. So this is the actual answer right here. That's what they want. So X can only be anything from 0 to 100 because that's the percent of games that home games that they win. Part C, assuming that the football stadium is filled to capacity when the team wins 60% of its home games, what is the capacity of the school stadium? Okay, so what we need to do here is take that 60 and plug it in to this equation. Two, 1,340. So the stadium's capacity is 21,340. So I just used this equation, total number of tickets sold. A manufacturer of a particular item has fixed monthly cost of $500 and variable cost of $15 per item, and it sells the items for $30 per item. Write a function that models the profit from the production and sale of X units of the item. So the cost function, you have fixed cost of $500 plus variable cost of $15 per item. The revenue function, the revenue is the money coming in, is $30 per item. So profit is the money you have coming in minus the money that you are putting out. Okay. So the profit is the revenue minus the cost. But when you subtract that cost function, make sure you put it in parentheses. All right, from there we need to distribute the negative, which just changes the signs of everything inside. And from there, just combine things of the same. We have two terms with x's, so 30x minus 15x is 15x, and then bring down the minus 500. So that is our profit function. Part B says what is the profit if 140 items are sold and produced in 1 month? So that means X is equal to 140. We need to plug that in. And you can put that in your calculator exactly like that with the parentheses and everything. And we get 1,600 is our profit. Part C says, what rate does the profit grow as the number of open items increases? What rate of growth? Okay, so the rate of growth, which is our slope of the profit function, that is the 15. They don't put it, you don't put an X on it, you just want the 15. Okay. Oh, and we are done with section 4.2.